Hey guys, welcome to our first meeting for our office hours. We hope to make it a recurring event. We will be meeting once a week to start with. We'll see how it goes. We may make it more frequent or less frequent, depending on the response that we get. So far, we have received a bunch of questions, all very reasonable, very interesting questions that I will try to go over all of them and do some demonstrations. Thank you for sending the questions. And if you would like to ask something during the office hours call, please use the chat pod in Zoom and I will be getting to it, I guess, once we get to the actual question and answer part. I have prepared a presentation that I would like to start, and then we'll describe the format and how we're going to do this. And this is an experiment. Well, it's like a well-known experiment. A lot of other companies do this, but we'll see how we're going to work it out just to make it the best use of time for everyone. And so we can provide the information and make it as efficient and effective as possible. So let me share my screen, and I will jump right into my presentation. The idea is simple, is to provide feedback to you guys, and as far as answering questions or any kind of new things that are going on in a very compressed format. We're going to spend an hour. The agenda is going to be the same for the time being. We're going to pick a topic of the day, and the topic of the day that I pick is really based on the majority of the questions that we have received via email. By the way, if you would like to continue joining us, feel free to send the questions in advance. So you can send them to info@backendless.com. And then based on the questions that we're going to get throughout this week, we're going to pick one topic that hopefully addresses the majority of the questions. And then for everything that is not addressed, which is going to be, I'll be answering the questions and doing the demonstrations, which basically is going to be the Q&A part of this office hours. So the topic of the day that we're going to have today is really just the app development with Backendless, the structure for developing applications with Backendless. Sort of a best practice for how one would go about building an app with Backendless. And this is the practice that we follow in our consulting practice, because in Backendless, we also build applications for customers, and all those applications are based on Backendless. It is really our requirement. And it really boils down to these 6 steps from the process perspective. So I'm going to go over these steps and give you an idea of how we approach this, and it is really a proven practice. I believe it works out quite well in the most efficient manner that yields some really good results architecturally with a lot of benefits, and I will describe what those benefits are. So the steps are, as you can see them here, the very first step is defining the user interface and user experience. So that we call it UI or UX first, which means that before you do anything else with your design and architecture of your app, define the user experience. And that could mean defining the mockups, storyboards, layouts, just really everything that depicts what your application should look like on the screen. The closer it is to that pixel perfect design, the better, because this way you will know exactly what you need to be implementing on the UI, and you know exactly what kind of data you're going to be working on with each individual screen. Not everyone has access to a graphics designer, although if you do, it's great. If you don't, it is still okay, because you can create mockups and create layouts as primitive as they can be that still indicate individual steps in your application. And that's what really matters. Once you define your mockups and storyboards and your UI, the next step that we do is really identify the entities that exist in your application. And those entities is really just those, for the lack of a better word, really blocks of data, just the things that your application operates with. If it is a, let's say, order processing app, then you're going to have an order, you're going to have an order item, you're going to have a product and a customer. Those are the entities. And those entities will exist in every single application. If someone's coming kind of like me, the old school of building apps, that's really your classes, and you're going to create your class entity diagram. Although it is really, I think it is kind of old school now, but for me, it never fails. Anyway, once you have that, and you know what the entities are in your application, the next step that we do is coming up with the actual schema. And the schema is how you capture the data at the database level, defining your tables, defining the relationships, defining what each individual entity, the kind of properties that it has. And those really become columns in the database. We'll go through a little exercise where I will demonstrate what it really means. Next thing is defining API services. And we will talk about API services. I think it is one of the subjects that is overlooked greatly when people build applications with Backendless. The benefit is huge. And I think it's very important to understand what those benefits are. So the next step is defining API services. That really becomes the mediator between UI and the actual database. Once the API services are defined, you will learn some things about how the data is worked on, because those API services will work on the data, and it's going to be a good opportunity to go back and refine your data model. If you need to reestablish some relationships or redefine the relationships or provide some additional properties in the database, that's the time to do it. And once all of that is done, you are prepared to actually start parallel tracks. If you have multiple developers where part of the team or a developer works on the UI implementation and integrates with API services, and another developer, if you have a liberty to have multi-member team, could work on the actual backend and cloud code to implement the API services. And then those two tracks can go in parallel, which will really speed up development of your application. I realize that this is still fairly high level, but it should really give you a vector, kind of a direction that is recommended to take when building apps with Backendless. So to put this in perspective, let's review an application, and it's going to be a very trivial app, which is, I cannot say it is my favorite, but from the perspective of demonstrating something, it is a very well understood problem, which is building a to-do app. So I took some sample UI, found it on the web. We'll be publishing this presentation, so credits, really give a link to the designer that put it together. This is all in public domain. And as you can see, the app, again, to-do app. So here we have a list of, we have lists of tasks, which is kind of this is done a little differently than a traditional to-do app. So I selected this for a reason, because to add a little twist to the actual data model. So we have a list of lists, and then each individual list has a collection of tasks. And a task may have a due date, individual lists may have colors. So those are kind of the properties that we have in the UI. And assuming that you have defined that user experience, and we have it right here on the screen, let's start drilling in and defining the entities. So the entities that we have here are fairly obvious. So first of all, there is a user, because a user has their own tasks and task lists. Individual, and then every single list has its own title. As you can see right here, it's trip to Paris, my tasks, and it has its own color. So those are the attributes of the list entity. And then individual tasks right here, we can see they have a title, such as buy milk, plan weekend outing, and so on. They have a due date, which is optional, as we can see, some tasks don't have the due date. And there is also marking of whether it is completed or not, which is also an attribute of that entity. So this is the exercise of defining the entities in your application. Once that is done and you define those entities, the next step is to create a data model. And the data model, I put it together right here on this slide. This is a screenshot from Backendless application. And what I did is I basically translated the entities that we have identified here into the data model. And as you can see, in fact, I will switch to my application. So this is the app where I defined these entities. So in the schema, if we look into the task, actually, let's look at the task list. So here we have color, we have title, and I define the relationship, which is one-to-many relationship to a table called task. An individual task has due date, has a property, whether it is done, and the title. So this is how I define my task. But task list has a relationship one-to-many to task, which means that a single list may contain really 0 or more tasks. And to create the relationship from the user, because user owns 0 or more lists. So if we go into the user table, in here, I created the relationship column called tasks, and it points to the task list. From what we have seen, the questions that people post in the support forum and just questions that come up in the discussions, defining relationships seems to be one of the harder challenges that people run into. But relationships is really what makes your application powerful, especially in Backendless, where you have a very rich capability of retrieving data through relationships. So identifying those relationships between the entities and capturing those relationships as related columns is one of the most important tasks that you have when you are defining your schema. Maybe in one of the future office hours, we'll do the whole session on just how to properly define relationships and how to work with them from the API perspective, because that's where one of the most powerful elements of our API is, and just how to work with relationships, how to structure those queries. But anyway, so here, as primitive as it is rather demonstrative of how to model it here. And as you can see, users, it is one-to-many. The property is called tasks, points to task list. And then task list has one-to-many column called tasks, points to a collection of tasks. All right, so that was the DB schema. Next step is API services. Before we jump into the API services, let's talk about the value of API services. So what the majority of the applications that we see do is you define your database, and the database has its own API, and that API can be used really from anywhere. And a lot of applications, they just start using that API directly from the front end. And it is okay, but it is not ideal because there are some negative side effects of that particular model. In fact, if you are building front end with other no-code tools, or even if you write it with code, so it could be native code that uses Android, iOS, or you could be building it with Bubble or whatever, you can integrate that UI directly with the database API that we provide. And not just the database, login API, or working with files, or sending out push notifications. Those APIs are available. And they can be secured where it may be okay to use them directly. However, let's say that you build that application. Let's say it is a mobile app, and you publish them to the App Store, and something needs to change where in the actual logic of your application. And the way to do this, if this is how it is modeled, is you have to put that new logic, and whether it's like running a query differently, or loading more data, or applying some security checks, or doing something in the system that needs to happen based on some conditions. So if this is how you model, then your only option, well, for the most cases, is to update the front end and re-release your front end and pre-publish into the App Store, which is not the most the best approach, because that means that you have to wait till the users upgrade that app and start taking advantage of the new functionality and so on. Of course, another option in this case, it's probably the only other option, is to modify this functionality. It doesn't work all the time, is to do the injection of your logic into the APIs in our cloud code, where you can inject before and after event handlers. And if you're not familiar with it is, we will talk about it again in some other installment of our office hours. But still, it is not very beneficial. And here's another thing. Let's say if your application uses some other third-party APIs, and you have API keys that you put into your application, it means that they're being exposed. And then in our case, in case of Backendless, exposing API keys is okay. API keys and backendless are not meant to be secure. They're really meant to identify that you have, a REST client or Android client or iOS client. Securing backendless data is done through custom roles and permissions and so on. But for other third-party services, if you are using their API key and you baked it into the logic of your UI, it is exposed. Anyone can really take a look at your application, view source or decompile and get a hold of that API key. So it really becomes a problem. And those problems, such as updating UI or hiding your API keys, can be solved with API services. And the architecturally, what it means is that you basically put something in between your database. And then here it says database, but it really means all other things in Backendless, such as user authentication, working with files, working with messaging, everything, right? So you put another thing here called API services. And what you do is you say that your front end communicates with API services, and API services being the cloud code that runs on our servers in Backendless. They do the rest. They can communicate with the database. They can communicate with third-party services. So all the API keys would be inside of the API services, like third-party API keys. And that becomes an approach where you can really shift a lot of responsibilities from the UI into API services. And that's where you encapsulate the majority of your business logic. The benefit of this is huge. So for instance, if you need to modify how you run some queries, to perform some additional checks and logic and so on, you do not need to release new version of your front end. Your app is running, it is installed, users download it, install it, it is there, but you can just simply, well, as simple as it is, but simply modify the logic inside of your API services. That is our cloud code. And all of a sudden, you can start enriching your application without people re-downloading it. Sort of like those, on the over-the-air updates for Tesla, where you have a car or any other EV, and you just basically start doing something different without you doing anything. Same thing here. You modify your API services, you enrich the functionality of the front end. And then, of course, just like I mentioned with the API keys, they are encapsulated here. So the front end does not have any of the third-party API keys or any secure information. So that is the approach that we recommend. And here, this is kind of the summary of the benefits. So, or some additional things that you need to keep in mind. So API services can be created with codeless JS, Node.js, and you can take advantage of pretty much everything that NPM has, like all the Node package NPM modules that are available. You can use them in your logic, or you can do it with Java. Since it is running on the Backendless side and Cloud Code, all the APIs that are available in Backendless are available within API services. So you can run all the same queries. And actually, since it is a cloud code, we consider it secure environment, because what's on the client side, it is not secure. People can look into it and see what's in there. API services considered secure environment. In fact, any logic that runs in API services in Backendless uses a special API key that is called server code or cloud code API key. So that API key is meant to be secure. You do not need to publish or release it in any way. It must be running within server code. For the reason that whenever you use server code API key, and then if you don't know what I'm talking about, if you go into the manage, you will see this cloud code API key. So this guy is meant to be super secure. You do not want to expose it, because whenever you run an API with this cloud code API key, it opens up some additional capabilities. And those capabilities do not exist with any other API key. And those capabilities, such as like logging in a user just by object ID. And there are other things that I just don't remember, but that is definitely the case, that it exposes and expands the capabilities. And in Backendless, you can create unlimited number of API services in your application. There is no limit, so you can create as many as you want. Now, so with all of that being said, with API services, let's go back to our to-do app and identify what those API services are. So just by looking at the screen, we see that one of the operations in our API services is going to be get users tasks lists, which is going to be a function that just returns a list of lists, right? And then here, the data that needs to come back would be the list name, color, and the collection of tasks inside of that list. We see that there is this add list button, which means that there needs to be a function that creates a new task list. And then there is no UI for the form, but you can imagine that it would take list name and color. The reason I'm writing it up like this is because that's exactly how we do it. We look at the UI and we see and we identify what individual operations in the API services are going to be. Most of the time, it correlates one-to-one. You will see for more complex UIs that some structures of data are being reused, right? So whenever you see really UI kind of replicating structurally, it means you can actually reuse the same functionality of your API services between different screens, which is also fantastic because reuse is what makes your application being developed faster and running more in a kind of lean way. The next screen right here, where we have a list of tasks, you can see that the operations that we would have in API services are get list details, right? It gets a list of individual tasks with due dates and whether they're done or not. In here, there's little kind of a bar chart that indicates a number of tasks in various lists. So you see their lists have different colors. And in here, for these colors, you can sort of take a look and see, that the red one, whatever it is, has more tasks. In order to implement this, there would be a method in API services that returns number of tasks in each list and individual colors. So based on the result of this method, we can render this part. Creating new task, this button, there will be an endpoint to create a new task. And then marking a task as done, that's also a separate API method. So that's how you end up with those API services. If you have a team of more than one developer and you would like to start developing in parallel just to get to your MVP or the release sooner. And the key, of course, in app development is to create as many parallel tracks where individual developers can move as quickly as possible is parallelism. So you want to create those parallel tracks. API services provides another benefit to make it happen. And the benefit is that you define those API services. And in order to get the UI developer moving quickly, you can actually implement those API services with some mock data, which means that API services initially do not need to go and communicate with the database. You can hard code those responses that will provide some sample data exactly in the same data structure as you would have it when it goes live. But creating mocked API services, you're essentially getting a UI developer off the hook where they can start moving and start consuming those API services as they build UI. So creating mocked version first opens up an ability, just unblocks UI developer to start implementing. And then once they are moving and implementing UI and integrating with the server, if you have another developer who can focus on API services, they start building all the business logic, implementing those API services, and then essentially then at some point swapping the mocked version with the version that they're building. And that's really the model that we follow when we develop applications. It's been proven, it works, and this is why we're talking about it here, because a lot of questions that came up were specifically on how to structure it here. So the first question that we have is really just on the best practice for the cycle of writing code or developing logic, testing and deploying. The way and that of course also implies that you may have schema in your production application, and you may have changes coming in as you're developing. So the way we typically handle this, and what we recommend, is to delineate your environments with separate apps. So you may have an app that is a production app, and that's the app that is being actively used. Your development environment and your staging environment could be just clones of that application. And to create a clone of the app If you go to the main dashboard, there's this clone button. And then right now mine is on trial. Whenever app is on trial, the clone doesn't work. So, but you clone that application and it becomes an exact replica of your production app with the same schema, same permissions, same business logic, everything is identical. And same thing that you can do for your staging application. So once you accumulated changes, let's say in your develop application, if you go to manage and then sync changes, if you have multiple apps, and I do have a bunch of different apps here, okay, but you will have the apps that represent develop, stage, and prod. What you can do is let's say you are in develop, you can select an app that is the staging. And once you selected that app, you click inspect, and then you will get a summary that lists everything that has changed between your develop version and staging version. And then in there, in that summary, you can select what you want to synchronize, whether you want to synchronize database changes or changes in the permissions and so on. And then you say, okay, synchronize. Then two applications will be synchronized where changes from your develop will be upgraded or will be migrated to the staging app. Then you go into the staging app, you run all the tests, make sure that everything works. And then you go into sync changes, and then you select your production application and apply changes using this sync changes facility. And this way, that way changes can migrate from develop to staging to production using this mechanism. Some questions that are on the UI builder side. And for this, I will switch to front end. And the first question is how to dynamically set CSS properties of a UI element. Okay, so let's create a new page and let's call it CSS props. Ignore everything that you see here because I'm actually logged in as myself and I'm what we call system developer. I get to see a lot more that you guys don't see yet. Like for instance, you see this automations button that I cannot tell you a lot, but that's something that is being worked on. So eventually many things will start showing up in the future releases. So CSS, how to dynamically apply CSS. Here's a solution. Let's go to theme and in here create an extension and I will call it demo extension. So an extension is essentially, you can call it whatever you want. This is not significant. In here, you can define your CSS classes, okay? And let's say that my class is going to be called red. And I will set the background to red. I think I can do it just like that. And I will also create another class called green. And then background will be set to green. And by the way, I haven't prepared for this part. I'm just, if anything that I'm typing here is wrong, please let me know. You can just drop in a chat message. So now we have two classes, red and green. And let's say that in our user interface, we will have a blog. Okay, so this blog, I will give it an idea of my blog. And there's also going to be a toggle. And then depending on the state of this toggle, we want to change the style of my blog to either red or green. Okay, so for this, I'm going to go into the logic of this toggle. And in the onChange event, I will update page data with the change value. Okay, so for this, I will say object set property in page data. And we'll call it is on, for instance, and then put the changed value. So the is on, when I toggle, will be either true or false, right? So depending whether it's on, we want to have it as green, and if is on is false, we're going to have it as red. So how will that work? In my blog right here, if I go to its logic, we have this class list logic, and the class list logic handler can determine what class from the extension to apply depending on some other conditions. So in here, in the class list logic, what we can do is we can apply the following logic. So we're going to test the property is on in the page data. Okay, so if it is true, then we can return a list. Well, we can return the class name green, and if it is false, it is going to be class name red. And in here, I think that needs to be a list, and that's we will check that if it is a list or not. So with text green, and that's the name of the CSS class. And otherwise, it is going to be red. So let's see how that works, or if that works. All right, so, and here it is, I changed the toggle, and then the color, the background color of the block is changing. Okay, so this is the way to do it if you want to apply classes dynamically. Just to go over one more time with what I did. So in the extensions, I defined my CSS classes, red and green. And then in my toggle, whenever I click it, I set the property in page data to indicate what the current state is. And the property name is on, and then the changed value, which is the value of the actual toggle. And then finally, in the block itself, in the class list logic, this one is going to be triggered anytime when the underlying data model changes. So whenever is on is true, I return a collection of classes with just one. And in this case, the class is green, and otherwise I return it as red. And then this is the result that we get. So this was the demonstration of how to apply classes dynamically. Another question that we have is how to scroll to a component and how to focus on a component. So let me create another page and scroll and focus. So in here, what I will do is I will add a button, and that button, I will call it focus. And I will also add a input component, and that input I will call my input. Okay. So let's say whenever I click this button, I want to set the focus on this input component. And by the way, you can set, using the same approach, using the same logic that I will demonstrate, you can set the input component when the page just simply loads. So here, select the button, and in the onClick event, we have this, I think the component, no, it's going to be device API. We want to set the focus on the component. Here it is, get component, my input. So whenever button is clicked, we want to set the focus on the input component. Let's take a look. So click the button, and you see the focus is now on the component. I can start typing, and it is an active component. Let's also use the same page to demonstrate scrolling. Okay, and for this, I will add a block. And I will change the background color of this block to something that we can recognize. So let's just like this bright green. Okay. And let's call this block as my block. This is the one that we'll be scrolling to. And just so it is somewhere further down the page, let's add another block somewhere in between. And that block will make it the height of some just, let's say, 2000 pixels. Okay, so this green block is further down. And then let's clone this button, and let's call this button scroll. So whenever this button is clicked, we want to scroll down to that green component. And let's go into the logic of this scroll button, and then use the scroll to, and then select our component, and let's change this to my block. So we will be scrolling to the my block. And let's run this page again. And then here, if we click scroll, it scrolls down, and then until this one becomes visible. If there were something under that green component, it would scroll all the way to the point where green is really at the top of the page. But since green is at the very bottom of the page, there is nowhere to scroll further. It scrolls down to this position. And that's just how it works in the browsers. So that's the demonstration of the scrolling and focusing. Okay, next question. Is it possible to allow the user to drag and drop components on the screen of an app? At this point, there is no built-in capability. However, we are going over various ideas of how to make it possible. Technically, it is possible. It's just not possible out of the box. And we definitely want to make it a possibility. So that will be coming in UI Builder. Okay. All right. Next question. How would I go about localizing in UI Builder codeless user interface to make it multilingual? Great question. So at this point, once again, that's another area that we are actively experimenting with. And the idea will be is that you will be able to provide bundles of different translations. And whenever you assign a value to a button or a label or whatever, like for instance, the value is scroll. So you will be able to identify some kind of ID in here. And if that ID is present in the translations map, then it will translate automatically based on the locale of the user. And that's kind of our vision. So we're experimenting with it now. But right now, there is no built-in capability for the translations. All right, next question. I would like to see how to go from registration page to another page and pass the user ID to that page. So the data is populated that in that page belongs to that particular user. Okay, let's quickly set up a demo for how that would work. So I'm going to create a new page, and I will call it source page. And I will also create another page, and I will call it target page. All right. So in the source page, just to differentiate the two pages, I will add a text, and I will call it source page. Let's make this guy a little bigger. So source page. And in the target, I will do the same thing, add text, and set it as target page. And again, let's make it a little bit bigger. All right, so now in the source page, let's add a button that will really simulate just like the user asked about the registration form. So we will have a button, and the click of that button will redirect to go to target, go to the target page. So let's say when we click this button, we want to, on click event, we want to redirect to another page. And for this, if you go into the app router, you do have this go to page. And in here, you specify the name of the page that you want to go to. Now, to pass any kind of data to that target page, you have this data connector. And this data connector accepts object. So in here, in the object, you can just create a new object or pass any existing object. And let's say the property is going to be user ID. Okay. And since this is what you were asking about, and to simulate this, let's just say that the user ID is ABC123. Okay. And notice that the property name is user ID. Now, in the target page, let's open that guy, target page. We will add another text and bind that text to the property user ID. Okay, the same property that we used in the source page. All right, and let's take a look at what's going to happen when we run source. So in here, when we click go to target page, notice that the ABC123 was instantly displayed. We didn't have to write any code. So how did that work? So in here, let's review. When we click this button, we set the property user ID, and the value is this. And on the target page, whenever it is open, any data that you passed in with this go to page instantly goes into the page data, which means that the user ID property that I specified from the source becomes a property in page data. And then this guy is bound to user ID that comes from page data model right here. It says right here, page data model. which means that as soon as the page opens up, all the data that we received is placed into the page data model, and that triggers the re-render of all the components, including the component that shows up that user ID. Okay, so hopefully that answers the question of how to send the data back and forth. All right. Let's see. There is also one other question to talk about logging API. So logging API in Backendless, it's fairly straightforward, but there are some things that you need to know about. So first of all, let me actually go to, and we can use this page since we're already on here. So on page enter, let's take a look at the logging API. So here there are really just 3 blocks. There is a log a message, set logging policy, and flush log messages. Whenever you use these blocks, what happens is that any data that you pass in here through these blocks will travel to the server and will end up in the server side logs. Okay. If you want to use some kind of local logging for debugging, you can just use print statement. Okay. And then the print statement, and just type in entered target page. Okay. So whenever you use this, it will run locally in browser's console. In fact, if I run this page and open up inspect and go into console, you see this message right here, entered target page. So that's what the print does. However, if you use logging API, you can log a message. And in here, there are 3 things that you can select. One is the logger name. Second is the log channel. And third is the log message. So logger name is sort of a logical unit that will be used to associate the message that you're logging in the logs. And then here you can say target page. The idea is that the logger name needs to identify where that message came from. So you can put the page name, or you can put whatever the functional area of your application. And in the log message, you can just put whatever message you want. Just entered the page. So that will be the log message. And then the log channel, there are multiple log channels. Okay. So the significance of these log channels is such as that if you go to backend and select log management, you see that there is an application-wide log level. Okay. And then it goes from all to off. And then each level includes all the other ones. So for instance, if I select trace, it means that everything that is located above trace will be also included. And if you select fatal, it's going to be just fatal log level. So it's kind of, goes from really nothing to everything. So you can define how verbose your logging is. You can control the log message format, which really comes from, I think, kind of Java logging. You can just Google Java logging format, and this will apply. And this is going to be the format for the individual line in the log file. And then the log file policy is whether a new log file is created for every day, or if you have fixed file size logging, meaning that as soon as the log file reaches that size, a new log file is going to be created. Okay. So in here, these are individual log levels. And since this application has never used any kind of logging, this is all you get. However, as soon as some logging starts showing up, there's going to be more on this page where you can configure log levels for individual loggers. All right, let's go back to logic. And in here, you see that we have a logger called target page, and the log channel is debug, okay? Which is good enough because we enabled everything, so debug will show up. Some other things that you need to keep in mind with logging. We have this set logging policy, okay? So this thing is rather important. Logging, if you use it a lot, it could become very chatty because you could just, start bombarding server with your log messages, which is not very good because you'll be eating up the API calls, which you don't want to do. API calls, you get some of them are included. Well, a block of them are included with the pricing plan that you're on. So what you can do is you can configure logging policy where in this case, as soon as it accumulates 100 messages, or every 2 seconds, it will send out a block of log messages to the server. And in here, you can customize. You can say, well, as soon as there is one message, send it out to the server. Okay, so in fact, logging policy should probably come before you use log message. So once you set the logging policy, our SDK running inside of the UI Builder application will follow, and it will do that. So in this case, as soon as there is one message, or every 2 seconds, it will flush out whatever you want, whatever you have accumulated as far as log messages to the server. Also, if you want to flush it out on demand, like for instance, when you're exiting an application, or you were, when you have enough, you just want to send it to the server, you can just use flush log messages, and that also sends the log messages to the server. So in this case, if we were to run this page, we know that those log messages will go out to the server. In fact, if we switch to network, we see that here's this log request with our messages was sent to the server. And in here now, if we go back to the backend, and that's not good, but let's go to files. And in the logging, we have this log file. And if we take a look, here it is. We have this log that was sent from that page that now is in the log file. Okay, so this way, as more things are happening in your application, you will have them in the server-side log file. Okay, so that's how the logging API works. So I see there's a bunch of questions in the actual chat that we have accumulated today. Let's take a look. All right, compiling into an app. So whenever you have an application, and I assume this is like delivery for mobile. So whenever you build an application in UI Builder, first of all, of course, make sure that, in the mobile version, you have the right layout and so on. Whenever application is ready, there are 2 options to deliver it to the mobile users. One of them is by using Backendless Viewer. And Backendless Viewer is an application that is already deployed in both Apple and Google App Stores. In fact, let me find one. Backendless Viewer, Apple App Store. There you go. So this is an app that we already published in there. Okay, here it is. And then Backendless Viewer is an application that is that acts sort of like a directory of applications. So whenever you publish your app using this publish the container, so in here, if your application is on the Cloud 9 or Cloud 99 plan, you can select this checkbox, and then your application, in addition to being published as a web app, will also going to be registered with Backendless Viewer. And whenever you do this and it's registered with Backendless Viewer, and you run Backendless Viewer, you will see a directory of all apps published to Backendless Viewer. And this way you can just tap your application, and then your login screen will come up, and you can actually bookmark it and say, this is my favorite app. And the next time you run Backendless Viewer, it will launch, your app will launch automatically. The benefit of this is that it's sort of like instant availability of your app in the App Store. You lose your branding because your app is going to be available through Backendless Viewer, but you instantly can deliver it to the app. So if branding is not important, then this is a very kind of quick and easy way to get your app to your users. If that is not an option, what you can do is publish your app. And then whenever you publish your app, you select the directory, and then this directory is going to be a directory in Backendless file storage. So whenever this app is published, you will go to the backend, to the files, you will locate this web directory or whatever it is, and you zip up this directory. That will basically give you an archive of all the HTML, JS, CSS, everything. And after that, if you go to GitHub, Backendless, and in here, you will find a project that is called, you find it, Native Mobile App Shell. Okay, this guy includes all the instructions of how to build a native app that includes your UI Builder application. And really, it becomes a hybrid app. So by following all of these instructions, you will end up with a build for Android and build for iOS that can be published to the App Store. And there are apps in the App Store, so we know this approach works. Apple has no problem with it. It's very easy to publish to the Google App Store. The benefit of this approach is this. in UI Builder, whenever you build your applications, in the actual logic for your app, there is this native API. And then this native API provides a bridge between UI Builder and our native app shell. So the things that you can do natively in Flutter, because a mobile shell isn't Flutter, you can add your code in there and do whatever you need in native code and communicate back to the UI Builder application through these blocks. And so essentially the bridge of communication between UI Builder and native code is already in place. And that is a function of this native mobile app shell right here, this project right here. It is open source. You can start modifying it. But at the very minimum, follow the instructions for how to bundle your UI Builder application with native mobile app shell. So by doing this, you essentially get a hybrid application that has native umbrella that provides all the native functionality for registering for push notifications or getting contact list, asking for permissions, and so on. In fact, here's a block for registering for push notifications, and mobile app shell does that. So that's kind of the strategy for getting your UI Builder application to your users, either through through Backendless Viewer or your own application published to the App Store. One of the questions is there a way to do a keyword search across an entire app project to find all instances or references to table names, properties, variables, text values, and or other elements in codeless logic? There is no simple way that would be available in UI Builder or Cloud Code. However, keep in mind that any codeless logic translates to code. In fact, I don't know how many people noticed, but we did an update some time ago where anything that you do in UI Builder for all the codeless logic, you can actually see the code that it generates. And this is going to be the JavaScript code. So for whatever logic that you see on the screen, if you click code, you'll see exactly the code that is generated. And in a lot of cases, the code is quite clean and readable, unless you start calling function from function and some other things, then you will see some weird IDs and so on. But for the most part, it's going to be pretty much exactly the same code that one would write if you were to do it with code. So given that everything is translated to code, one way to do this is if you go to Backend, select Files, and in here, select UI Builder, you will see here a folder called Containers, and these are the UI containers. And then inside of the containers, you will see pages. This is going to be for every single page, there's going to be a directory. And what you can do is you can just search in here, but I think it's going to search just the file names, not the contents. Yeah, so there's no really simple way. One way, you can zip everything up, download, and run the search within files. And that will produce some results. Like for instance, if you're searching for a table name, but inside of the actual Backendless console, I cannot think of a way where you can quickly, from a single point, run a search and find all the logic that references a specific table. All right, is there security embedded in page generation to ensure that backend calls actually come from the generated page? And I assume what you mean by this question is that whenever backend receives a call, you want to make sure that that call comes from that specific page. No, the web model is such that if you look at any given page, you can see what calls it is making, and you can spoof that call from even Postman to make it happen. All right, so unless that page is being signed and it has some kind of key that it received from the backend, and that key is being passed in as one of the arguments, it still can be spoofed. So I don't think there is a sure way to provide that level of guarantee. API services are great. Yes, they are. But am I right in understanding that the pricing table that the plans are limited to 5 or 10 cloud code scripts? Does this include API services and not only event handlers and timers? So no, API services are not being counted as cloud code scripts. That's why I was saying that you can create unlimited number of API services. The number of event handlers and timers is going to be limited to what we call cloud code scripts, but API services do not go into that count. So you can create unlimited number of API services. Is there a way to architect for reusability, componentize across apps? Yes, there is, and that is not very well documented at this point. But the idea is that you can create a component, and it could be a custom component or reusable component, and there's going to be a button somewhere here to publish it to the marketplace, which I think it is not available yet. So the idea is that once you create a component, you can publish it to the marketplace, and that will make it reusable across apps. The caveat is that once it is published to the marketplace, it is available to everyone, because there is no concept of closed marketplace yet. It's something that will be coming. But the idea is that a component, although maybe it is going to be on the actual component level. Like, let's give it a quick try. Like, for instance, if I make this reusable, demo component. And now in here, edit. Yeah, so there is no, I do not see oh, here it is, published to marketplace. All right, so yeah, so once a component is created, you can publish it to the marketplace using this button. Although if your app is on trial, you cannot do that, for the reason that if someone publishes it on trial and the component becomes available and that person goes away and does nothing with Backendless, then there is no channel to get support for that component. But you can publish the marketplace and it will become available for everyone. So that's kind of the caveat. All right, let's continue with other questions. It is not clear if cloning an app is included in the pricing plan of the app. So if your app is on trial, like for instance, this app I created, I think this morning. So you see, it says on trial. So if it is on trial for Cloud 99, then cloning is not available. Once your app is actually on the pricing plan out of trial, then you can clone your app. Hopefully that answers your question. I see that someone implemented multilingual support. So if you could post to the support forum, just as an article, we'll be happy to promote it to the knowledge base section of the support forum, describing how you did it. That will be fantastic. All right, so here's another question. A user has multiple forms on a page, and I want a specific form to be displayed after the user logs in, depending on the user ID. How is that done? There are different ways you can actually get this done. So for instance, you can attach the visibility property for a form. So let me say, we can use just block, right? So let's say block. Here's block 1, and let's give it a color, and let's make it red, and let's clone this guy, and then make this green. Okay, and then each block may contain other elements. So in here, if you go into the logic, you do get the visibility logic. So this visibility logic can be driven by either just data binding to a property. So if a specific property in your data model is true, or the value evaluates to true, then it will be visible. Otherwise, it's going to be hidden. You apply this to each form, each block that you have in your component. And whenever the page loads up, you inspect that user, and then you update the data model to have a property that corresponds to the form that you want to show. Okay, so for instance, let's just quickly simulate that scenario. Okay, let's call this red block, and this is green block. And in here, in the visibility, we can just red block. Let's do it a little bit differently. Let's go into the visibility logic. And in here, what we will do is, in the logic, we will test a property in page data. we will do it like this. So if we have, we call it block visibility. So if block visibility of page data equals green, it's going to be simple like this. So if it equals green, then it's going to be visible. Okay, and in fact, we will copy this thing and then go into this one and then modify the visibility. This one should actually be green and the other one should be red. So on this one, it should be red. Okay, and then on the page itself, so here's the page itself. Let's remove all of this. And what we will do is we will set a property in page data. Property is going to be block visibility. And we will set it to green. And let's run this page. There you go. So see, only green is visible. And then if we change this to red, then only red is going to be visible. There you go. Only red is visible. So that's how I would solve this problem, is that each individual block is tuned in to be visible only when certain conditions are met. Is there a way to find some documentation on the native API blocks? Not yet. So we recently published UI Builder documentation. If you guys don't know about it, so if you go to Docs, UI Builder, these are the UI Builder documentation. It has a bunch of different stuff, and a lot of it is quite useful, especially on data models and data binding. So a lot of work went into this. So this will be enriched with all the additional information, including the native blocks that we have. Until then, please go to the support forum and ask there. If an API service needs to process a large number of objects from an outside search, it will inevitably throw an execution timeout. What is the best way to create a queue of data to process so as to avoid execution timeouts and avoid peaks and cloud code processing? Great question. So whenever you have a stream of data coming in, such as constant updates, don't start processing right away. So basically have an endpoint that receives this data and adds it to a queue. And that queue could be a database table. It could be a file that you keep on appending data to. It could be, we're going to be releasing a new function, actually kind of a whole persistence system that we call Hive. I think it's the first time I mention it, but it's a super exciting system, and Hive supports different data structures, and queue is going to be one of them. So you can just start queuing things up, and then have a separate facility, and that's going to be timer that periodically wakes up. And rather than saying that the timer is responsible for processing 20, 30, 100 items, timer basically just grabs the next one from the queue, processes it, removes it from the queue, goes for the next one in the queue, processes it, removes it from the queue. And that timer will run for however long is allowed by your pricing plan, 5 seconds, 20 seconds. If you bought additional extension packs or function packs, it will run longer. But the timer basically stops, and it processed as many as it could. Next time the timer wakes up, because you could have a schedule, it just checks if there is anything in the queue left, and if there is, it grabs the next task and processes it. And that's how you basically work on emptying out that task. So that's a way to handle it from the queuing perspective. So hopefully that answers your question. Is it possible to dynamically generate CSV files based on a data query for an app user to download? Great question. And the answer for this is yes, it is possible. And we're actually in the process of documenting this approach. So I think it is already published. If you go to Marketplace and select API services, one of them, I think it is already published, is going to be, and there's this one, CSV to Excel. Okay, so this is a plugin that has a ton of CSV related functionality. You can run database queries to generate CSV files. You can import CSV data into the database. You can run the conversion from CSV to just a list of data objects. The list of data objects to CSV, it supports a ton of functionality. And the reason we haven't announced it is because just the sheer process of documenting it has been just a monumental process. So as soon as we finish documenting it, there will be a formal announcement, but I believe this is already in the marketplace. If not, please let me know, but I think it is. So if it's not there, it's going to be published very soon, because once again, my view is kind of skewed because I'm logged in as Mark, which gives me special privileges. Anyway, so that is, if it's not there, it's coming very, very soon. I think we're done for today with our office hours. I hope you guys found it useful. If there are any more questions, please fire away. I'll be here for a few more minutes. But if not, thank you. This is recorded. We will be publishing a video with everything we discussed today. And for the next office hours, they will be Wednesday next week, I think. Send your questions to info@backendless.com, and we'll be happy to continue this. Hopefully, it will become a tradition. And I'll see you all next week.